Question number 1. Find the eigenvalues and eigenvectors of matrix A. This is matrix A. Now, the determinant of matrix A is equal to 0. If you check, this reduces to lambda squared minus S1 lambda plus S2 is equal to 0, where S1 is the sum of elements in the principal diagonal. So the sum of elements in the principal diagonal is 4 plus 2, which is equal to 6. S2 is the determinant of matrix A. S2 is the determinant of matrix A. The determinant of this matrix, this is 8 subtracting 3, it's 5. This becomes lambda squared minus 6 lambda plus 5 is equal to 0. Is equal to 0. Lambda 5 1 negative. Lambda is equal to 1 5. These are the eigenvalues of this matrix. These are the eigenvalues of this matrix. We know that A subtracted lambda I into x is equal to 0. This is the characteristic equation which is used to find the eigenvectors. This is nothing but 4 minus lambda 1 3 2 minus lambda into x1 x2 is equal to 0. What you are supposed to know is that the eigenvectors always they are not equal to 0. Not equal to 0. Okay. Now you multiply rows by column. This is 4 minus lambda into x1. Okay. Plus x2 is equal to 0. This is 3x1 plus 2 minus lambda into x2 is equal to 0. These are equations 1. Case number 1. Case number 1. If lambda is equal to 1, equations 1 become, if lambda is equal to 1, 4 subtract 1, this is 3x1 plus x2 is equal to 0. This is 3x1 plus x2 is equal to 0. If you check the two equations, it is the same equation repeating itself. It is the same equation repeating itself. So if the equation is repeating itself, you take one equation, 3x1 plus x2 is equal to 0. Bring this x2 to this side. This becomes 3x1 is equal to negative x2. Okay. Divide both sides. Divide here by 3 and divide here by negative 1. Okay. This is x1 divided by negative 1 is equal to x2 divided by 3. This is not, it's not difficult, it's not something complicated. If you check, if I want to go back here, you just do cross multiplication. 3 by x1 you get 3x1, negative 1 by x2 you get negative x2. Remember, the aim is to find this eigenvector, which is supposed to be in the form x1, x2 like this. So you should make sure that the numerator is x1. Here again the numerator is x2. It simply means that x1 is equal to negative 1, 3. So this is the eigenvector corresponding to this eigenvalue. Okay, case number 2. If lambda is equal to 5, equations 1 become, if lambda is equal to 5, 4 subtract 5, this is negative x1 plus x2 is equal to 0. This is 3x1 plus 2 subtract 5. 2 subtract 5, this is negative 3x2 is equal to 0. This equation becomes negative x1 plus x2 is equal to 0 if you factor out negative 5. So the two equations that we have now is this and this. Okay, again you have the same equation repeating itself. What are you supposed to do? You take one equation, negative x1 plus x2 is equal to 0. Bring x2 to this side, negative x1 plus negative x1 is equal to negative x2. Divide both sides by negative x1 is equal to x2. If you check, this is something like this. So x2 is equal to 1, 1. So this is the eigenvector corresponding to this eigenvalue. We are done with this question.